Imagine a world where a slender predator with feathers stalks among huge conifers, chasing prey with terrifying intelligence and incredible speed. It is not a movie hero, but a real inhabitant of the ancient Earth, a velociraptor. His name is now shrouded in a lot of myths and distorted ideas. In fact, it was a dinosaur that had little to do with the Hollywood idea. Its physical structure, lifestyle, and hunting skills have become the subject of fascination for many paleontologists and prehistoric enthusiasts. Diving into the world of this predator opens up a whole new perspective on how intelligent and adaptable these prehistoric creatures could have been. The velociraptor was no giant or beast capable of tearing through fences. Its strength lay in other advantages: cooperation, quick reactions, and above all, a body adapted to active hunting. Thanks to fossil finds and scientific studies, we are now able to uncover not only its appearance, but also its way of life, diet, exercise, and communication. If you think you know everything there is to know about the velociraptor, you'll be surprised. Come with us to immerse yourself in a world where he ruled not only with teeth and claws, but also with cunning and ingenuity. Contrary to popular film belief, the velociraptor was not a giant bald lizard with leathery skin, but rather a slender creature with a feathered body, more reminiscent of modern birds of prey than a monstrous reptile. Its body measured approximately 2 meters in length, but only reached about half a meter in height. The weight was around 15 kilograms. The head was elongated and fitted with sharp, jagged jaws. 3 fingers with hooked claws grew from the forelimbs, while the hind limbs had the characteristic sickle-shaped claw on the second finger, its main weapon. The whole body was covered with feathers, which is confirmed by findings from Mongolia, where fossils preserving feather prints were discovered. Its appearance was probably very lively. The body was light but solidly built. The tail was stiff and reinforced with bony protrusions that maintained balance during running and jumping. Although the velociraptor was not directly capable of flight, its feathers had important insulating and communication functions. Scientific evidence shows that it could communicate with other members of its species by its coloration or gestures with the help of feathers. His eyesight was excellent. His eyes, located in front, allowed him binocular vision and precise targeting of prey. This predator inhabited the Earth at the end of the Cretaceous, approximately 75 million years ago. Its home was the area that today corresponds to the territory of Central Asia, especially today's Mongolia and part of China. Paleontologists have discovered its fossils primarily in a geological formation known as Jadochets, which was once a dry and windy landscape with sand dunes and scattered vegetation. Unique survival strategies have probably developed in this area, adapted to environments with limited water and extreme temperatures. The ecosystem in which the velociraptor lived was inhabited by a variety of animals, from small mammals and pterosaurs to larger herbivorous dinosaurs, such as Protoceratops. It is with this dinosaur that the velociraptor is often associated. The famous discovery of 2 fossils that died in a duel is one of the most iconic evidence of their interaction. The landscape of Cretaceous Asia offered ample opportunities for predators such as the velociraptor, terrain full of hiding places, land prey, and many smaller animals to target. Hunting was not just a matter of speed for the velociraptor, but rather a combination of tactics, intelligence, and surprise attack. Its long legs allowed it to reach high speeds, while its slender body and strong sickle-clawed hind limbs served as a deadly tool. This claw was able to pinch, stab, and tear the muscles of its prey, usually attacking the victim by jumping from an ambush. Some theories suggest that he may have used cooperation, that he did not go hunting alone, but in groups, thus increasing the chances of a successful attack. Although group hunting has never been 100% confirmed, evidence from fossil footprints and similar behavior in related species suggests that velociraptors may have acted in coordinated formations. They attacked prey from behind or from the side, often aiming at weaker individuals, young or injured animals. Their agility made them capable of quick maneuvers, and while they were not physically strong, their hunting method was efficient and deadly. The diet of the velociraptor consisted mainly of small to medium-sized vertebrates. It could hunt small animals, such as lizards, mammals, or birds, but it would also take on larger opponents if necessary. Paleontologists have found fossils that contain the remains of smaller dinosaur bones in the area of its stomach. One of the most significant finds is the aforementioned scene of a fight with a protoceratops, which may have been part of its diet. In addition to fresh meat, in some cases, it could also eat carrion, especially if it was injured or sick. The claws, gills, and teeth were adapted to tear flesh, not to crush bones. Its sharp jaws worked like a knife, easily dealing with soft tissues, but probably leaving the firmer parts of its food to other creatures. Such nutrition required a constant search for food, and it was almost constantly on the move, ready to attack or feed on other people's prey. His movement was a combination of speed, agility, and precise balance control. Thanks to his slender body and strong hind legs, he was an excellent runner. Its long limbs were equipped with strong muscles that allowed for rapid acceleration and rapid changes of direction. This was essential for hunting. He had to surprise and catch the prey before it could orient itself. The long tail, reinforced with bone rods, acted as a stabilizer. It helped him maintain balance during running and jumping, and allowed him to make sharp turns without losing speed. Despite its feathers, the velociraptor was not capable of flight. His arms were too short and his body too heavy. However, forelimbs with feathers may have helped to balance or control the direction of the jump, similar to wings in flightless birds. It is even speculated that he may have glimpsed briefly from a height, for example, when attacking from a high place. His every move was graceful and targeted, making him one of the most mobile birds of prey of his time. The brain of a velociraptor was quite large compared to its body size, suggesting a higher level of cognitive abilities. According to research, it had excellently developed frontal lobes responsible for visual perception and could also exhibit a certain degree of social behavior. This has led some paleontologists to believe that the velociraptor was not only an instinctive hunter, but understood the context and was able to learn from experience. His intelligence may have been the key to success in coordinating hunting tactics or bypassing obstacles in the environment. Many scientists consider it to be one of the smartest theropod dinosaurs. While there is no direct evidence of gang cooperation, the complexity of its brain allows for assumptions about shared roles in hunting or other interactions within the group. This ability to think and react may have played an important role in surviving in a competitive ecosystem. Like other dinosaurs, the Velociraptor was oviparous. Females lay eggs in simple nests dug in the ground or made of plant material. Fossil evidence shows that they built their nests carefully and laid their eggs in circular or spiral formations. Some related species have been found to have adult fossils lying directly above the nest, suggesting that they may have warmed their eggs with their own bodies, similar to today's birds. It is therefore possible that the Velociraptor exhibited some form of parental care. The eggs hatched into chicks, which were probably covered with fine down and were fully dependent on the protection and guidance of adults. Since life in Cretaceous ecosystems was dangerous, few young survived to adulthood. The pressure of predators and the need for rapid independence shaped the behavior of young individuals who had to quickly learn basic survival skills. Therefore, evolution supported the Velociraptor's instincts of caring for offspring, which may have increased their chances of survival. Although it was a predator itself, the Velociraptor was not at the top of the food chain. Its environment was inhabited by larger carnivores that could threaten it, such as larger species of dromaeosaurids or other theropods. It was precisely because of his smaller body size that he always had to be vigilant. It could fall prey to larger predators, which easily overwhelmed it if caught outside its group or resting. In addition to natural enemies, it also faced competition for food. In periods of drought or lack of prey, conflicts could arise between different species, which often ended in injury or death. These were not only direct enemies, but also opponents who could push him out of the territory or steal his loot. Ingenious tactics, speed, and the ability to hide were therefore his main weapons, not only in hunting, but also in surviving in the ruthless world of the Cretaceous era. Velociraptor was one of the key links in the food chain of the late Cretaceous. Its role was comparable to that of today's medium-sized carnivores. It helped maintain balance between populations of smaller herbivores, thus indirectly influencing vegetation and the amount of food available to other animals. By focusing on vulnerable individuals, he kept herds of weaker dinosaurs in healthy shape. At the same time, his hunting activities offered leftovers to scavengers and smaller predators, thus promoting biodiversity. Due to its adaptability, high intelligence, and wide range of food, the Velociraptor was able to quickly integrate into a variety of environments. It was not tied to just one type of landscape, which allowed it to respond to changes in the ecosystem. From the point of view of the dynamics of prehistoric communities, it was therefore an important predator of the second line, not the largest, but very effective. Its ability to survive in groups, nest, protect its young, and successfully hunt made it a strong competitor in the complex ecosystem of the late Cretaceous. The fossilized footprints of velociraptors provide a fascinating insight into their movements and behavior. In some cases, a complete series of tracks have been found that point to running, stopping, or even fighting. A typical feature is the imprint of 3 fingers of the hind limb, while the second finger, the one with the sickle-shaped claw, often does not touch the ground at all. This finger was raised during the run so that it would not wear out and was ready for immediate action in the event of an attack. The fossils not only confirm the shape and size of the claws, but also the way the Velociraptor actually walked. From some trace finds, scientists also deduce behavior. For example, possible group movement, hunting, or even hunting for prey. Findings in sediment layers more than 70 million years old show that the Velociraptor was able to move even in difficult terrain. The fossils of its footprints thus became an important source of information about its body dynamics, its weight, and also how often and intensively it moved. Paleontologists can also estimate its speed or running style, which gives these ancient prints extraordinary scientific value. The study of the Velociraptor is one of the most dynamic branches of paleontology, since new finds are constantly emerging that change our ideas. Scientists use a variety of methods, from traditional excavation and cleaning of fossils to modern 3D scanning, sequence, and microscopic examination of bone structure. Particular attention is paid to feathers and soft tissue imprints, which can reveal details about the way of life, metabolism, or evolutionary links of the Velociraptor to today's birds. In addition to the bones themselves, paleoecological data also play a role. Geological layers, rock composition, the presence of other species. In this way, scientists are trying to reconstruct the whole picture of the environment in which the Velociraptor lived. International research teams from Mongolia, China, America, and Europe collaborate on research, share data, and discover new forms of interpretation. Thanks to advances in technology and an increasing number of specimens being found, the image of the Velociraptor is becoming more accurate and more complex than we ever imagined. One of the most interesting discoveries of modern paleontology is the fact that the Velociraptor has more in common with today's birds than we might expect. It is classified as a dromaeosaurid, a group of theropod dinosaurs that has a direct evolutionary link to birds. The similarity in bone structure, the presence of feathers, the way eggs were laid, and the internal structure of the bones show that birds are not a completely separate group, but that dinosaurs, such as the Velociraptor, did indeed evolve. Although the Velociraptor did not have the ability to fly, its anatomy carried all the prerequisites for later lines of development to acquire this ability. We have an exceptional animal in front of us, a predator that ruled the earth tens of millions of years ago, but its genetic heritage survives to this day in every sparrow, falcon, or eagle. This connection between the past and the present is one of the most fascinating proofs of the evolutionary history of life on our planet. The public's image of the Velociraptor is strongly influenced by film adaptations, especially the famous Jurassic Park series. There, the Velociraptor is portrayed as a 2-meter, bald, and extremely powerful hunter that can kill adults in one jump. However, this idea has little to do with reality. The real Velociraptor was significantly smaller. It was barely half a meter high and up to 2 meters long. It was lighter and had feathers that gave it a bird-like appearance. His strength lay in agility and sharp claws, not in brute physical strength. Another difference lies in behavior. The film's Velociraptor is presented as a highly intelligent predator, capable of opening doors and planning attacks, while the actual level of intelligence, although high by dinosaur standards, was not such complex thinking. In addition, the film image was probably based on a different species, a larger and bare Deinonychus, which corresponded better to the film dimensions. The realistic Velociraptor was a fascinating and exceptional creature, but not a miraculous killer beast from Hollywood. Despite being a predator himself, the Velociraptor had to be prepared to defend itself against stronger opponents. His main defense strategy was speed and the ability to escape. At the moment of danger, he was able to retreat in a flash, change direction, and disappear into the terrain. Thanks to its slender body and stiff tail, it could maneuver sharply, even between rocks, vegetation, or shallow canyons. Stealth were key. Its feathers may have even had camouflage coloration to help hide it from larger enemies. In the event of an imminent threat, the Velociraptor was also able to defend itself with the help of a curved, sickle-shaped claw on its hind leg. It could deliver a defensive blow. Its jaws were sharp, but they were not strong enough to fight the giant theropods. That is why. He relied mainly on escape, the moment of surprise and cleverness. In extreme cases, it could also resort to aggression, especially when it came to defending the nest or young. When the Velociraptor was first described by the American paleontologist Henry F. Osborn in 1924, it was perceived as a typical lizard-like predator. The first fossils discovered suggested that it was a small but dangerous carnivore with a long tail and curved claws. The idea at the time was influenced by the limited amount of fossil finds and the knowledge of dinosaurs in general at the time. It was not until the 1990s and 2000s that the image of the Velociraptor began to change fundamentally. New finds from Mongolia and China have revealed the presence of feathers, opening a whole new chapter in his interpretation. Scientists began to see the Velociraptor as a feather-covered creature that was much closer to birds than previously thought. Advances in CT scans and analysis of brain cavities have brought new insights into his intelligence, sensory abilities, and social behavior. Today, the Velociraptor is considered a key species for understanding the transition from classical theropods to real birds. The fascination with the Velociraptor is a combination of science, aesthetics, and pop culture. Unlike giant predators such as the T-Rex, the Velociraptor stands out for its grace, speed, and intelligence. People see him not only as brute strength, but also as strategy, agility, and elegance. In addition, its appearance has changed significantly in recent decades, making it a symbol of scientific progress and discovery. Each new information about this predator increases its popularity. People want to know the truth about a creature that has long been misunderstood. Another factor is its significant representation in the media. From books and movies to documentaries and those, the Velociraptor has become an icon of dinosaur culture. Despite the necessary correction of factual errors in films, for many, he remains the embodiment of the dynamism and excitement that prehistory offers. At the same time, it has also become a symbol of a new scientific approach to dinosaurs, in which feathers, behavior, intelligence, and ecology play an important role. The evolution of the Velociraptor is part of a larger story of theropod dinosaur evolution that leads to today's birds. The ancestors of the Velociraptor appeared as early as the Jurassic period, when the first smaller light carnivores with elongated limbs and improved sensory apparatus began to appear. Over time, some lines began to adapt to fast running, jumping, and effective hunting for small prey. From these forms evolved a group of dromaeosaurids, to which the Velociraptor belonged. The specific development of the Velociraptor led to the creation of a predator that was perfectly adapted to an active lifestyle. It had large visual lobes, a powerful balance system, and perfectly built limbs. The presence of feathers indicates an advanced stage of development in which it was no longer just a terrestrial reptile, but a creature close to birds. The evolution of the Velociraptor is an example of the transition between two worlds, the world of classic dinosaurs and the world of birds as we know them today. Thank you for immersing yourself in this fascinating story. If you liked the video, I will be happy for a subscription, like, and comment. It helps me create more adventurous expeditions into the world of dinosaurs. Thanks a lot.